Okay, so let's look at a bunch of problems from Chapter 5 and Chapter 6 as a review here. So let's start here. Find the area of the indicated region under the standard normal curve. Okay, so what they're showing is the standard normal. So what we see is they're giving us the z value of negative 1.30, and they want the area to the right. All right, so we have to remember is no matter what we do to look up these values, everything is going to be based on giving the area to the left. So if I want the area to the right, I'm going to have to do 1 minus whatever area I get to the left. All right, so in order to find the area to the left, I'm going to go ahead and bring up Excel here. And I can use equals norm dot sdist, and then I'm going to ask for the z of negative 1.3, and again here I have to then put true, right? And that's going to give me 0.0968. So this is 0.0968, and so this would be 1 minus 0.0968. Let me fix my minus sign there. Okay, and that's going to be D here, 0.9032. Okay, on the next one, area of the region under the standard normal curve. All right, again, we want the area in between here. So we're going to have to look up these two z-scores, one for 211 and one for negative 0.45, and subtract the one at 2.11 minus the one at negative 0.45. Okay, so let me bring back this. All right, equals norm dot s distance, a distribution, and so I'm going to start with the 2.11 true, because that's going to be the bigger one. All right, and then what I'm going to do over here is do the one for the negative 0.45. Whoops, I forgot the true. Okay, and this. And then I could have Excel do the subtraction for me. I'm going to do this one minus this one, and there's what I should get. So if I put these numbers back in, so what I have, again, I had about 0.9826 minus 0.3264, and that's going to leave me with C 0.6562. All right. Area under the standard normal between z equals 1 and 2. All right, so basically it's the same as the problem we just did there, except we're not given the curve. So here's your 0 point. And then let's talk 1 and 2. And so again, we're going to have to do the area up to 2 minus the area to 1. So let me go back here. I could actually modify this. So the first one will be up to 2. The second one would be up to 1. And I should get that 0.1359 as a result. So this amounted to 0.9772 minus 0.84. 0.413, and that gives me A there. All right, determine whether the graph could represent a variable with a normal distribution. All right, a normal distribution is always going to be symmetric. This is not symmetric. It's skewed. And remember, it's skewed. We talk about where the tail is. So this would be skewed right. Okay. SAT test scores normally distributed. Mean test score was 1481, so that's mu equals 1481. And standard deviation, again, we're talking population here, so sigma is 292. All right, and we want to find the z-scores for each of these values. Okay, so let me show you how we're going to do this. We're just going to do converting to z, because we essentially have x values here that we want to convert to z. So we do x minus mu over sigma. So the z-score associated with the 1930 value would be 1930 minus 1481 over 292. Your x value minus mu over sigma. And if you do that, you get about 1.54. Okay. And then if I repeat this for 1340, for 2150, and for 1450, whoops, sorry. All right, don't know how to get rid of that right now. Okay, 1450 down here. I keep doing that. 1450. I'm going to give you the calculated values here. This one you get negative 0.48. Here you're going to get 2.29. And here you're going to get negative 0.11. So those are the z-scores with each of those values. And we want to know, are any of the values unusual? Well, unusual would be more than 2 standard deviations away from the mean. So this one here would be unusual. Okay. Find the probability of z occurring in the indicated region. Okay. This is really no different than the ones we were doing before, because if we're saying the probability of z being less than negative 0.59, that corresponds to the same thing as the area that's in here. So I would simply go back to Excel, and I'm going to do this one down here in case I need the one up there for another calculation. So norm s.dist negative 0.59, and I forgot the true again. All right, we get 2776. And there we are. And remember, we could take that area directly because that was to the left of the z value, and that's what we're looking for. Okay, standard normal distribution, the probability of z being between negative 2.50 and 1.50. Okay, well, that's exactly, I'm glad I kept this other calculation here, but that's a difference between two. So we're actually going to do the 1.50, what happens there. Okay, and then subtract the negative 2.50, and we should get 0.9270 about. So there it is. So again, this one looks like this. We have 1.50, and we have negative 2.50, and we're looking for everything in here. So we did the value here minus the value here to get our 0.9270.